Uh, Tarun, how are you, man? Thank you for joining us.
Hey, how's everything going? Sorry I couldn't be there, but happy
Dude, no
to
worries.
join.
No worries at all, man. Well, dude, thank you for joining. And yeah, man. So what we're doing is we're basically trying to go through everyone's background and kind of from the lens of what the students can learn to kind of do the kind of smart decisions that you made, right? So like kind of your decisions from the beginning to now. And yeah, I thought maybe it'd be fun to start like literally like from college and just like let's hear your background. And I'm sure at some point I'll have some anecdotes to throw in there too. But
Yeah, for sure. So, I studied math and sort of applied physics in college. I was going to do a PhD, but then sort of got convinced to take 1 or 2 years off and go work at DE Shaw. And so I worked at a place called DE Shaw Research on doing building hardware for simulating protein folding, which is exactly the opposite of crypto, you might think. Um, but while I was there in 2011, um, we were building some hardware. We gave this supplier like $25 million, and then they just ghosted us for 6 months. And then we were like, okay, when they came back, like, what the fuck? You took our money and didn't give us anything. And they were like, oh yeah, we'll give you a 10% discount. And we're like, you delayed our timelines like 6 months. I think that's worth a lot more than a 10% discount. You have to at least tell us why you delayed. Because like, yeah, yeah, and then the delay was like one of the earliest Bitcoin miners like bought up our chip space. So like we were building this hardware, and there's only like a fixed amount of factory space effectively in the world for hardware. 90% of it, 95% of it is owned by like the majors like Apple, Samsung, whatever. And so there's a very large there's kind of this like fight for the whatever remnant space there is. And the suppliers are a little bit shady, and yeah, I guess they took a bribe or higher payment from one of the first Bitcoin miners. And that was when I was like, people are willing to go to the extreme of like buying up kind of like expensive hardware space for this. So that was, I guess, when I was like, okay, well, I should first off try to go run a miner. And I did that. And then, of course, I sold everything in 2013 because I saw the first crash. Then I was like, I'm not going to do this again. um, but at that time, I was more kind of like how I think a lot of people I have observed viewed 2017 or 2021, which was like, hey, the number went up. I'm just going to go try to, understand the financial aspect of it. But at that time, I was working in distributed systems, and people around me were all like, crypto's got to be a scam. It like violates this like theorem that in distributed systems is sort of like the fundamental theorem, which is like the CAP theorem, which says sort of a distributed database only kind of has these three properties that you might want, but you can only get two out of three of them. One is sort of consistency, which is, if I add a transaction to a database, it stays in the database. One is availability, it can keep taking new transactions. And one is partition resistance. If I split the network in two and then I'd rejoin them, it can figure out how to reconcile things. So, maybe when the network splits on one network, you put out a TikTok that got you canceled. On the other network, you put out a TikTok that won you a Nobel Prize, and suppose the two networks rejoined, which one wins? That's sort of one sort of way of thinking about the partition resistance property. And so kind of a fundamental result in distributed systems is you only get two out of three. And one of the sort of things about Bitcoin is it sort of promises you all three. Like you can keep sending transactions. Any transaction that makes it in after a while can't be removed. And, this thing is designed to be sort of partition resistant. But, so a lot of people in the computer science world kind of were like, this has to be fake because it doesn't work. And it actually just turns out you needed quite a different security model to get it to work. And this probabilistic security model was like quite hard to reason about. The original Bitcoin white paper had tons of math mistakes, like it doesn't compute certain Poisson expectations correctly, stuff like that. So like a lot of people who are more serious about building these systems before crypto started were sort of generally looked at it negatively. And I was like in that camp until 2015. And in 2015, sort of some of the first papers that were able to kind of like say like, hey, actually this thing is not violating physics and is not just, secretly a scam run by one person running one node. It actually is like there is a reason it works, and there's a reason that it works over the internet, and it's very, has different properties than, Amazon S3 or, a database you might use at a data center. And so that was when I was like, okay, there's clearly something here. And then in 2016, 2017, I guess Ethereum came out, and there was a lot of talk about proof of stake. And, very roughly, proof of work is, hey, I'm committing sort of some energy or resources and hardware to securing a network. Proof of stake is I'm committing sort of capital in the form of a digital asset to secure a network. And one of the weird things to me was that people were sort of arguing that they were sort of equivalent financially. Like if I put in $100 of hardware, it's an equal amount of protection for the network. Like it can secure an equal amount of transactions as, $100 of capital of some asset, which seems, and at that time I went into high frequency trading after working in hardware, and that just seemed patently false in the sense that like I could get a ton of leverage on the asset that I put in the network and maybe short it, and suddenly I made the $100 of security worth $50. Whereas with hardware, it's actually really hard to do that. I can't just like take over all of the world's energy and move the energy prices 50%. It's just like a very difficult market to manipulate in that sense. So it just like led me down this rabbit hole of like, how and when will this thing break and not break, and like how does the security model that people came up with for proof of work that took 8 years from the original paper for people to even like come up with the correct math for it. So that kind of nerd sniped me. And then that was sort of when I was like, talking to people who were entered the space in that time, 2017, 2018. So like, I'd known Nader, for instance, we both were at DeSo for a bit. We had some mutual friends, and trying to understand like what was real about what happened in 2017, because obviously there's a lot that was not. And one kind of curious thing that's worth pointing out is, every good lie has a kernel of truth, and I think that's true for every cycle in any kind of every economic cycle, right? Like there's always something that's a real innovation that like people are actually using, but then people go and like hyperbolically kind of try to reason about it. You could argue that a lot of the generative AI stuff right now is possibly reaching the point of being hyperbolic in that, you could imagine that it can do anything. So now people are willing to like fund it as if it's going to do anything, which is not totally rational. But I digress. So that sort of led me to start to make simulation software, kind of like what you have in trading for backtesting strategies, to try to stress test networks. Because there's a sense in which most of these networks are really running some sort of trading strategy. It's a database running a strategy against its users, or like counter to its users. And so, and sometimes you also have to treat it with the same security respect as trading strategy. It's not just like, hey, I move fast and break things, ship some random change to the database, so it broke everything. Okay, I can revert it, right? Like it's very much not like that when it's supposed to be money. So, that led me to kind of start my company, which in a very circuitous route, which we do a lot of risk and parameter modeling and stress testing for networks. So yeah.
Yeah, and Tarun, so I realized that we kind of jumped into your background before really telling them about Gauntlet, which you're currently working on. And so, my understanding is Gauntlet is kind of, the analysis and research that you guys do underpins a lot of major protocols, like including Compound, and other things like that. Maybe you can just speak to kind of the impact that this kind of rigorous analysis and the research that you've been doing has had on the industry, because I think that's really interesting to the students.
Yeah, for sure. So I think, I was talking about proof of stake economics being kind of like, hey, how do you think about it when you have these extra attack vectors? One of the main things that kind of, I would say, the 2020 and 2021 boom kind of took off because of was really, DeFi, which you probably just heard about. And that is a real use case, right? People were using stablecoins. They needed some way of borrowing, either earning yield on them or borrowing against them or borrowing against collateral, which is a very reasonable use case. And one interesting question you might ask, though, is like, how do you choose the parameters for what is safe in a permissionless system? Because in a permissionless system, there's no U-turns, there's no like takesy backsies other than like a hard fork, which is socially deleterious, right? And so there's sort of a sense in which that you have to really actually monitor kind of what safety means. And when you're talking about things like lending, different types of collateral can be better and worse at different times, right? Like in a certain type of market condition, maybe it is okay to allow people to borrow a lot against certain types of collateral. And when things are crashing or there's no liquidity, you actually need to restrict the amount of borrowing. So what we really do is we're monitoring a lot of DeFi protocols and running sort of simulation stress tests against them, and looking at, hey, do the current set of parameters, current set of risks that these things are taking, does that make sense? Or will it like kind of be unstable in that it has sort of like there could be a really bad event like a liquidation cascade where, a loan goes under, and when in the process of clearing that loan, you cause a bunch of other loans to go under, which causes the spiral, and then the system is not stable. And so a lot of what we do has basically, generated, hundreds of millions of dollars of revenue for liquidity providers in these networks, but also avoided, networks that don't have sort of active risk management and monitoring have had, hundreds of millions of dollars, almost $1 billion of losses, whereas, networks with very careful monitoring have had, sub 1 million. So it's sort of, it's sort of one of these things where it's like, hey, the people who actually care about doing risk management and monitoring in these systems can survive even the worst possible crash in the history of this industry, like last quarter. So a lot of what we do is like, we're the risk manager for a lot of DeFi protocols. And one thing that's really cool about this world that's not true in normal finance is that the transparency means that you can build a lot better models. So in the sense of in like a normal finance setting, let's say I'm I'm a bank or I'm a exchange, and I'm trying to decide how to set certain parameters, like, how much, what your margin requirements are, what the tick size is, what the fees are. I technically don't really have the data from all possible counterparts, right? I don't know the data from other exchanges. I don't know the data for every user. And so when I make those risk models, I have to make some assumptions about these other users. But in crypto, if you can accurately index all the data, you have a much clearer view of like who the risky participants are, when they're taking that risk, and like how they've behaved in a lot of different ways historically. And because the code is open, you can actually run these tests directly against the actual interfaces that exist, which is very, very different than normal finance, where you spend more of your time making a model trying to predict what someone else does, as opposed to just being able to run it directly.
Yeah, and I really love that like kind of explanation, because you're actually basically at the forefront of this insight, which is the transparency of DeFi and generally crypto, right? Basic can very clearly make more robust systems than the kind of opaque model that traditional finance or TradFi has today, right? And I think you're basically at the bleeding edge of how that happens, right? You're literally the one that analyzes all the protocols, makes sure they're not going to break, and then kind of over time that ends up being true, and then everyone moves from TradFi to DeFi. Woohoo! It's going to happen. It's going to be great. But I'd love to go back to your background a little bit, and I love it, Tarun, because it kind of feels a little bit like a series of nerd snipes. Not to oversimplify it, but
that is actually true.
So, but I kind of, if you ask me, it's kind of more like you're following what you're passionate about, which just happens to be a little bit correlated with being nerd sniped. But it sounds like basically the kind of hardware stuff you were doing at DE Shaw Research happened to come directly into, kind of head to head with Bitcoin mining, right? Which is such a weird thing, but basically Bitcoin mining pricing out life-saving DesRes research. It happens, here or there. And that you're kind of like, maybe we should look at what's going on here. But then it sounds like proof of stake really got you kind of in the, once kind of proof of work was well analyzed, that got you excited. Then you went to proof of stake. And I think you played a big role there, in helping, even projects like Ethereum that are really well known, formalize and actually be sure that it's going to work, right? And so, so I love that. And it kind of goes hand in hand with advice that Haseeb and Rob gave earlier, which is you're just kind of doing what excites you, right? And then you found a way to make, a good company around it and all this kind of stuff, which is awesome. This is great, man. So I'm going to see if anyone has any questions. Does anyone have any questions right now? Okay, great. So Tarun, we got one. I'm going to turn it to questions in just a second, but Tarun, I wanted to ask you, you're pretty deep on everything that's going on in, particularly in DeFi, but really anything that's crypto related, whether it's at the layer 1 level, L2, you analyze it all, right? And so for the students, we're having a startup competition at Princeton. They can launch a crypto track, or there's a crypto track and a non-crypto track. They can launch anything they want. And I'm kind of wondering, if they were to work on one thing as a college student, right, whether it's a part of this startup competition or like just generally, what would you kind of say, hey, like this is something that people aren't doing that they should be doing? And it can be as granular as like a specific idea or even just like a broad category of things, you'd be like, oh yeah, like, MEV looks interesting. I don't know, like, yeah. So what do you think? What's your take for the students on that?
Yeah, I think like one particular thing that has, it reminds me a little bit of 2016 Ethereum is just the fact that we're about to have this insane amount of capacity for generating code for zero knowledge proofs, and also the capacity for zero knowledge proofs is going to go up because there's been so much investment in both the hardware side as well as different proving systems, probably like, I want to say in the last cycle, $5 to $6 billion of investment into that world. And we have had a bunch of improvements in the software quality so that, you can write a ZK circuit without having to, understand exactly how it works. Now, you still have to understand a lot more math than, if I wrote Uniswap in Solidity, but you don't have to understand everything, which is a huge, like, we went from something where it's like, okay, it's theoretically possible to, okay, we have some proof of concepts, but you have to go write the circuits yourself in assembly and like understand all the fields you're using and like really, really basically have been the researcher who wrote the paper for the prover and like no one else can write them. To now we have, I wouldn't call them the most developer friendly tools, but they're like not horrible, like Circom, which, you can use to write different applications that provide you verifiable computation. And that seems to be a place where no one has figured out what the right apps are, other than apps that are sort of like crypto eating itself, like a bridge. Okay, fine. That's sort of obvious that you want to prove consensus to another chain. Like, but it's not like a new application, right? It's not an application that's like adding new users to crypto. It's an application that's just like moving around existing users, right? On the other hand, the fact that there's this huge modality and you can do much more complicated things, and you can kind of link off-chain and on-chain computation a lot more, means that there's some application. There's the Uniswap of ZK is sitting out there, and so far investors have focused mainly on investing in the infrastructure of like people being able to build these tools and systems. But at this point, I would say the bigger opportunity given how many, how much advancement we've had in the infrastructure side. The bigger opportunity is actually on the application side of like finding an application that takes advantage of zero knowledge proofs in a very unique way that gets net new users into crypto. Because I think the last part is actually very important, because everyone who's working in this stuff is also generally especially on the technical side, uh, has the maybe deficiency, as you point out, that I have, of like constantly falling for nerd snipes. But someone like Hayden was not really falling for nerd snipes. He was like, hey, Hayden, who made Uniswap. He was just like, hey, I read this blog post. I'm just going to implement this thing and see if anyone uses it. And I kind of feel like you need that attitude for making applications versus making, base layer infrastructure. And so I think, like, to me, that's like one of the biggest opportunities, I guess.
Yeah, Tarun, I will say I do think you've definitely made being nerd sniped a superpower. Like, I don't think there's any question in that. But that's really great. Your kind of feedback for the students, which I'll summarize, is like zero knowledge tech. It's basically not quite at the level where you can write JavaScript and get an app, right? But it's at the level where students can reason about it and maybe find really interesting applications.
You can do a hackathon project with the tools that exist now. It's not going to be polished, but you can do a hackathon, which was not true a year ago.
And they have 30 days. This is a month-long startup competition. It's more than a hackathon, but 100%. Awesome, man. So I'm going to turn it over to questions. So does anyone have a question in the audience? Okay, great. Let me give you the mic. Okay, give me a minute here.
Hi, Tarun. Thanks for talking. I had a question regarding layer one yields, like with proof of stake.
Yeah.
I know you have background on this, and you've obviously looked at a lot of protocols, and I was wondering, like, what sort of engineering decisions or bigger decisions go into deciding those yields? Because I looked at Ethereum for a bit and tried to figure out like what made their curve, like based on like how much stake is in the protocol and what yield they give, and it wasn't like super clear like what went into that model, and I was wondering if maybe you had insight on how they thought about that.
Yeah, that's a good question. I think most of the models for that, unfortunately, are mainly based on like replacement costs. So one of the things I think that was actually quite hard for the merge, and this is unique to Ethereum, I don't think this is true for like a net new proof of stake network like Solana or Near or something, is that you have this sort of notion of cost of replacement. Like, I have to convince all these miners to suddenly move, and they have a bunch of hardware expenses that they have to deprecate. And they literally chose a yield to be like, you get X% plus whatever the cost of deprecation is at that stake level. So like they took the data from different mining pools, measured the profit for different mining pools, and then basically came up with some, they had a fudge factor in the sense of like, they just were like, okay, well, you'll get this much more than if you were a mining pool of this size. And then that's how they fixed the curve. It is kind of heuristic. And part of it is like, economic design. Part of it was definitely like, what's the minimum issuance we can do to convince miners to move? Because like miners still are some of the largest ETH holders. So like they would have, if they like coordinated a fork at the time of the merge, that would have been very bad. That could have been very bad. Like, well, there was a fork and it didn't survive for a reason, because people's rewards were much higher by moving to proof of stake Ethereum. And so that's sort of a social thing mixed in, if that makes sense. It wasn't totally purely like, here's how we optimize the yield.
Thanks. Yeah, that's really interesting.
What an awesome question and answer also. Anyone else have a quick question for Tarun before we go to our next speaker? Okay, great. And Alex, I see you're here. Great to see you, man. I'm off camera, but we'll be back in a minute. We're just asking the last question for Tarun. So.
Yeah, I'll just ask a quick question. So when you were switching from, I guess, molecular dynamics research to blockchain, did you feel like it was because there was maybe like less to do in MD almost, and you were like waiting for like computers to get faster, and blockchain represented like a very exciting place to switch to? Or
yeah, it's a funny question. So yeah, my first boss at DeSo Research actually is the first author on the AlphaFold paper and runs DeepMind's biology unit. So like I definitely think it was more like there was only so much you could get out of that technique after a certain point, and then some of the AI stuff got good enough by 2019. But in between working at Desres on D-Sharp research and crypto, I worked in high frequency trading and did some hardware simulation stuff. And so that is actually where I got more of the understanding of like how should you stress test these things. So I did have like a middle step between them. But yeah, I definitely think like molecular dynamics is a little bit dead in a lot of ways. I think it has a chance to come back, but only if it's like used in hybrid with tandem with a lot of AI techniques. In fact, I mean, this is maybe divergent from crypto stuff, but you're starting to see that we're reaching kind of the limits of AlphaFold type of techniques right now. And so people are now trying to add in molecular dynamics again.
This is great. All right. Thank you, Tarun. Tarun, I have one more question for you.
Yep.
How do you look so stylish all the time? A lot of people they don't know this. You're one of like the best dressed people in crypto. I don't think people understand. What's your secret, you know?
Once I remember I was in India and this homeless guy was following me and like heckling me. And after a while I started listening to him and he was like, "Are you colorblind?" And of course I'm wearing like every color that exists. And that was when I was like, okay, I think it's just that I just see a lot of colors and I'm like, okay, I got to wear a lot of colors. I think it's very simple. It stems from that.
So you're born with it. All right. I get it.
Yeah.
All right. Well, dude, thank you so much for coming in. Also, are you in New York right now or in the next couple weeks?
Yes, I am.
Okay, great. We'll hang out. I think Alex is there and Rob's there. We'll make it happen. It'll be great.
Sounds
Thank
good.
you so much for coming, man. Really appreciate it. All right.